Hello there, thanks for tuning to my live stream and welcome to Excel Island if you're a new subscriber and welcome back if you're existing subscriber. My name is Abata Sherifdin, but you can call me Sherif. So basically what I do on this live stream, on this channel generally, is that I share content on Excel, Power BI, SQL and Python. But basically, and currently, I'm only focusing on Excel and live streaming my learning journey of SQL on the Datacamp platform. So my goal is to live stream my learning journey of data analysis in SQL career track on the Datacamp platform for the next 100 days. And I've been consistently doing that for the past 37 days. So earlier, before coming on live, I did a couple of lessons. So the 37 days learning streak have been achieved. You get it now. So my network was not pretty strong earlier. So that's basically what I do. I share content on data analytics, also on data analysis, Excel, SQL, Power BI, and Python. Basically focusing on Excel and SQL for now. But SQL is based on my learning journey on a data camp platform. So, but currently, right now, I also talk about freelancing, remote work, and tech in general, how to become a successful freelancer, and I also share tips that have really helped me so far for the last 2, 3, 4 years of my freelancing journey to get to the state that I am currently. Also, I have a coach who has been putting me through freelancing and remote work for the past 2, 3, 4 years now. His name is Benga Adebiyi, and currently he has a course called the Freelance Client Magnet course. You how to become a successful freelancer and run a successful freelancing business. You learn to become a successful freelancer on major platforms like Upwork, on Fiverr, on LinkedIn, and remote job websites. The course also teaches you how to charge premium for your service, how to position yourself, and have this the idea of charging and negotiation skills also with clients. Did you get it down? So the course link will be under the YouTube description. You can check it out. You can also go on Twitter, and I'll leave the profile link to Bengali Twitter account. You can check it there. Bengali also have a YouTube channel. You can just search Bengali on YouTube. You will get to his channel. But his Twitter account is Bengali. You can go and check out his pinned tweets where you're going to see a lot of testimonials from students who have been successful with freelancing for the past years with his experience of freelance as a freelance coach. He's a highly rated freelance coach. So do check out the course and use the link under the YouTube description to purchase the course. Let's get back to my live stream today, to my learning journey today. So basically, I live stream for like 30 minutes for 1 hour. So that is the amount of hours I spent, minutes or hours I spent each day learning. And the idea is to learn little by little and compound the knowledge over time. You get now? So now I don't want to watch like a movie and just rush through the whole course material. So that's not how we learn here. So usually I could have a couple of week areas to practice, but I've practiced that before coming live, but my network was not really strong earlier. So I'll just jump here and start this section of the course. So I've completed a couple of lessons. Let me quickly show you that on the platform, a couple of courses under this career track. If I go back to the learning dashboard, let me go back real quick. If I come to under tracks, career track, let's launch that real quick. So while that is coming up, let me just drop a couple of messages on the live. So you can see we have different career tracks on the platform. So you can check it out. But I'm currently on this data analysis in SQL career track, which contains 39 hours of learning, broken down to under or to 11 courses, under 11 courses. So I've completed a couple of courses. So you can see the whole track, the whole course hours is 39 hours, broken down to 11 courses with one project to complete. So I've completed five on this five. Yeah, 1, 2, 3, 4, 5. I've completed 5 courses under this career track. So I still have 6 more courses to go, then one final project. So that's the goal. So hopefully before the 100th day, I'll complete this track and I'll start the Power BI track also. I really want to improve my Power BI skills also. So and Python will be the last section I will take on the platform. So I'm under this section of functions for manipulating data in PostgreSQL. So let's continue the course. So the course is 4 hours. So the goal is to finish this section because this week, this new week that we are, or before the end of this week. So the goal, depending on how technical it is, sometimes I don't really understand the concept or the way the software is explained. Then I'll have to Google other material, other articles online and try to comprehend. So I think I did that when I was doing the data manipulation part in SQL, and it really helped me in my understanding of the concepts and the technicalities also. So let's start.
Welcome to PostgreSQL Functions for Manipulating Data. My name is Brian Piccolo, and I am a Senior Director of Digital Strategy. I will be your instructor for this course. You've learned some SQL fundamentals in your previous coursework. Now we are going to continue to expand your SQL knowledge by teaching you how to use built-in functions and operators to extend the capabilities of your PostgreSQL database. You'll be using the SQL database, which is a well-known example database that models a fictional DVD rental store. The database is highly normalized, which allows for great example queries and provides a great representation of PostgreSQL data types and custom functions. Before we get started, let's review the topics that will be covered in this course. First, in this chapter, you'll learn about some common data types and their properties and characteristics. Next, you'll dive into some built-in functions and operators and learn how to use them to manipulate date and time data. You'll then explore some frequently used functions for parsing and manipulating text data types. And finally, you'll get an introduction into full-text search using PostgreSQL extensions. Let's get started. PostgreSQL has a robust set of native data types. Some of the most common include text data types like char, varchar, and text, numeric data types like int and decimal, date and time data types such as date, timestamp, and interval, and finally, arrays. It's important to have an understanding of the properties and characteristics of the various data types anytime you are working with a relational database like PostgreSQL. Text data types like char and varchar allow for a fixed or varying number of characters and string data. Think about categorical data like the title column from the film table. Text data types typically represent character and string data, but can be an unlimited length. For example, the text from the description column in the film table. We'll explore how to extract, create substrings, and manipulate length. Title column from the film table. Allow for a fixed characteristics of the various data types anytime you are working with a relational database like PostgreSQL. Text data types like char and varchar allow for a fixed or varying number of characters and string data. Think about categorical data like the title column from the film table. Text data types typically represent character and string data, but can be an unlimited length. For example, the text from the description column in the film table. We'll explore how to extract, create substrings, and manipulate text data types later on in this course. Numeric data types, like int and decimal, allow you to store integers like payment ID and floating point numbers with varying precisions like amount from the payment table.
So if this is numeric, this will be decimal data type now, from what you said earlier. Like numeric data type, int or decimal. Okay, so this is an integer data type, and this is a decimal data type, but they are both called numeric data type. Okay.
We'll learn more about PostgreSQL date and time and array data types later in this chapter. When you are working with existing databases, there will be times when you will need to determine the data types of columns that you'll be working with. For example, if we look at the results from a simple select query on the film table, you might hypothesize that all the columns in this query have a text data type. But would you be right? Let's take a closer look. PostgreSQL stores information about all database objects in a system database called information schema. By querying certain tables in this database, you can determine information about the database, including data types of columns. The following query will return the column name and the data type for the columns we looked at in the previous slide. When you execute this query, you will get a result that looks like the following.
Okay, let's say select column name, data type from information schema dot column. So where column name in information is column names and table name is field. So what you are getting is the column name and the data type for each column from information schema. So where it stores, it says, okay, it says something information schema. Let me go back again. When you're working with the data,
Times when you will need to determine the data types of columns that you'll be working with. For example, if we look at the results from a simple select query on the film table, you might hypothesize that all the columns in this query have a text data type. But would you be right? Let's take a closer look. PostgreSQL stores information about all database objects in a system database called information schema. By querying certain tables in this database, you can determine information about the database, including data types of columns.
oh, cool.
The following query will return the column name and the data type for the columns we looked at in the previous slide. When you execute this query, you will get a result that looks like the following. If we look closely at these results, we see that the title and description columns are indeed text data types, specifically varchar and text. But we see that special features is actually an array. You'll learn more about arrays later in this chapter. Now it's your turn. Let's take a closer look at the customer table of our DVD rentals database.
Now let's practice. Okay, you learned about some of the common data types that you work with in Postgre, some characteristics of the data type, and how to determine the data types of the column in the existing table. Think back to the video and answer the following question. Which of the following is not a valid text data type in PostgreSQL? Valid text. Hold up. That should be string. We have text data type. We have char data type. We have variant data type. That should be string. That's pretty straightforward. So as we saw in the video, let me move this a bit closer to the screen. So it says, as we saw in the video, PostgreSQL. So as we saw in the video, PostgreSQL has a system database called information schema that allows us to extract information about objects, including tables in our database. So in this exercise, that is loading. So in this exercise, we look at how to query the table of the information schema database to discover information about the tables in the DVD relational database, including the name, type, schema, and the catalog of all tables and the views, and then how to use the results to get additional information about columns in our tables. So the instruction is to select all columns from the information schema table. Okay, so that is where it's storing the tables, the information about the table, the actor table, system database. Limit the result that we have public there will be public schema. Let me read that again. Select all columns from the information schema the table system database. Limit results that have a public table schema. Let's see. Okay. Let's look at that. So I think this is the actual table. This is a table. You don't want to get information about the table. You want to get information. Select all columns from the information. Okay. From Select all columns from the table system database. So that will be information, information dot underscore schema dot tables, where table dot schema limit the result to have a public. Okay, the table where table dot schema equals to public. So let's run the code and see. Oops. Filter by the schema where table equals to public. Exactly now. So that's not the error. Let's use AI to run the query. Oh, I didn't wrap it in quotes. This is a text data type. So I've forgotten that easily so fast. Aha, so my code was correct. I didn't just have the text. This is a text data type. I have to have it in quotes. Table schema that are public. The table name. This is what we have for the table name and the data type there. If I scroll to the right, I think you should see the data type. Yeah. Okay, I don't think it's there. These are table name, table type, base table, self-referencing. So this is giving us information about the tables, the name of the table, and other information like table catalog and stuff like that. So let's submit that. Okay. So the second instruction is to select all columns from the information the schema the columns system database. Limit by the table name to actor. Limit by table name to actor. So we want to select this actor table name and get the data type, I guess. So let's see that. Let's start from informations, the schema underscore schema. Okay. Underscore schema. Where table name is, where the table name here? So just copy that. The table name is the actor. What else get from the actor table? Just copy that there. Let's run the code to see. There's a mistake somewhere. So it's not seeing information. I'm not spelling this correctly. Information. So I put S there. Yeah, exactly. I'm not spelling it correctly. It has to be information, not informations. So it's returning public table names, actor ID, column names. So the table name contains, okay, the table name contains how many columns? 4 columns. Actor ID, last update, first name, and the last name. That's why. Ordinal position, 1, 4, 2, 3. Okay. Yeah, this is non-label. Yes, it can be null. Probably the content can be null. The data type is small int, timestamp without time zone. Please That's the last update. Okay. The character building, character building, character. Character limits can be null, some can be null, some can be null. This one is 45, 45. So I get information from each of our. That's cool. Let's submit that. Oops. My submission is wrong. Why? This is quite funny. Select all columns for information. Uh, System database. Limit by table underscore name to ask actor. I don't know why this is wrong again. Why I don't take hints. This is quite straightforward now. It's saying this should be tables. Oh, wow, this is funny. So let me change this to tables then. That's not possible. That would be wrong. Oh, really? Okay, let's see. What is the difference between columns? So if I'm selecting table, oh, okay, select all columns from the information schema dot tables. Okay, well, let me change it to dot columns first. The difference between columns and tables. So if I select dot columns, it's giving me the record for each what? For each columns in the actor table. Oh, okay, table name actor, column, okay. Information dot schema dot column name, okay. Now understood better. So I have to just say it should give me the tables, not the columns there. So it's already done one actor, one result for that base table, table type. Understood. Table dot schema here now. Is there now? So where is it? Ooh, wow, okay. Table dot schema is actor. Let's see. I'm not getting any response there. So that is wrong. Wow. What's wrong with this? Now what are we getting now? We are getting information about the tables where their schema is public. Let's submit that. Aha. So what was the error there? Let me read that again. It says select all columns from information underscore schema dot columns. The second instruction is saying under dot columns, it's not saying tables. Limit by table name. Name. Okay, let's see. Public. I'm trying to read the slides, the information from the slides. So the next, let's see this now. Oh wow. So earlier we're getting information about the tables. Now to get the information about the data types in this column. Okay. So the columns table of information schema. Hold up, let me read this again. If I come back here, okay, this given we're starting information about objects, including tables. So this will give you information about the tables. Okay. So once we get information about the tables in our database, that's why we use this one here. In this exercise, you will look at how to query. So in this exercise, we will look at how to query the table of the information schema. So we're getting the tables, information about the tables table. Okay, now I understand better now. This is giving information about the tables in the tables in the information schema. So, okay, okay. The next one, we want to get information about the tables. Let's see that. Okay, okay. Understood better. Now understood better. So if I go back here now, determining data types. So the columns table of the information schema database allows us to extract information about the data types of columns in a table. We can extract information like the character of string length or a char or a varchar column or the precision of a decimal or numeric floating point type. So using the technique you learned in this lesson, let's explore the customer table of our DVD rental database. Okay, select the column name and data type from information table.schema. So we want to query the columns in a particular table. Maybe the result will only include the customer table. Okay, understood. Okay, so then we can say get the column name and data type. Want to get the column name? Can just say column underscore name. They want to get the data type of those columns. Data type, data underscore type from system database information. So from this information, which is part of this is where the information about each table is stored in the database. But once you get the columns record, not the table record. For customer table, where the table is customer table, we're just writing the customer table. So if I go back here, this is the actor table. We want to get information about the customer table. Let's type customer there, customer. So if I run this code now, aha. So the column name for each in the customer, so we have the active. If the customer is say active, definitely this will be not, I'm just thinking based on the type of database that they are talking about. So this is showing whether the customer is say active or not active. The store ID, where the customer got the created date that the customer registered, the last update date. So these are the data type, the customer ID, the address of the customer, then and so on and so forth. So these are the data types. That's cool. Why are we telling him to select star there? Because I've used select star, but I don't use select star now. Colon name and data. I'm getting colon name and data type. Why are you telling me to use select star? I don't want to use select star, but let's use select star. If I want, let's see if I get the same information. It's just giving us information about the database, and I don't want that. Why asking me to use select star? So it's saying try select star again. It will probably say wrong submission again now. Come on, this is saying custom. The instruction is saying customer table, and I'm guessing it should be actor table. Why? Is something wrong with the Datacamp platform? Imagine a instruction. I'm following the instruction. You're asking me to do something else. That's not fair. So now we understand how to get information about the data types of our columns in a table. So we understand how to query those tables. I think that's cool. So let's look at, oh, we're 30 minutes into the live stream. Let's look at dates and time. Let's finish this, probably to this section.
Next up, we will learn about some common date and time data types. Understanding how to work with these data types is crucial for preparing and extracting data for machine learning and data science. In this lesson, you will learn about the precision and features of timestamps, intervals, and date and time types. You'll find that most of the date and time data you'll be working with in SQL will have a timestamp data type. Timestamps contain both a date value and a time value with microsecond precision. These data types are very common because they can be used to record an exact point in time, like when a payment was made, or a record was last updated. Timestamps in PostgreSQL use the ISO 0861 format, which is a 4-digit year followed by a 2-digit month and day, separated by dashes. If you look in the payment table of the Sequela database, you'll see what this format looks like. Notice that the values contain both a date and a time value with seconds precision, whereas the example above was at the microsecond precision. Next, you'll look at date and time types. When you only need to store a part of the timestamp in your database, the date and time types may be better options. Date and time types are essentially the date and time values of the timestamp. As you see in this example, date types contain a date value with no time of day, while time types contain the time of day but without, you guessed it, a date. If we look at the create date from the customer table of our DVD rental database, you'll see an example of a date type. Finally, interval types store date and time data as a period of time in years, months, days, hours, seconds, etc. For example, 4 days. Intervals are useful when you want to do arithmetic on date and time columns. Here you'll see a query where we calculate an expected return date based on a 3-day rental duration by adding an interval of 3 days to the rental date column from the rental table in our DVD database. We can use the same technique that we learned in the previous lesson to determine information about a column with a date and time type by querying the information schema system database. If we look at the rental date column of the rental table, you'll see that this is a timestamp. However, you'll also notice the without time zone reference. PostgreSQL provides you with the ability to store timestamp and time data types with or without a time zone. While this comes in handy in certain situations, most of the time you'll work with timestamp values without a time zone, which is the default behavior. Now it's your turn. Let's take a closer look at date and time data types in the exercises.
So most of the time you work with date data types without a time stamp attached. Which of the following is not correct? Timestamp data types contain both date and time values. Timestamp, both dates and time value exactly. These data types uses year, months, DD format. Yes, that's correct. Interval are representation of periods of time. Interval. Time data types are stored without a time zone by default. Time data time. So intervals, periods of time. All of them are correct. Timestamp contain both date and time. Exactly. These data types use and YY correct, while the interval types are representative of periods of time. That's also correct too. But time data types are stored with a time zone by default. Time data types are stored with a time zone. They're also with a time zone now. Exactly. They're also with a time zone. That's not correct. But interval data types are representative of time zone. Time data types are stored with a time zone. So that's not correct. Let me listen to that again. I wanted to read that today. So hold up. I wanted to check something. It's a great job. Time data types can be stored with a time zone, but they are stored without a time zone by default. They can be stored with a time zone, but they are stored without a time zone by default. So interval data types provide you with a very useful tool for performing arithmetic on the date and time data types. For example, let's say our rental policy For example, let's say our rental policy requires a DVD to be returned within 3 days. We can calculate the expected return days for a given DVD rental by adding an interval of 3 days to the rental date from the rental table. We then we can then compare the result to the actual return date to determine if the DVD was returned late. Let's try this example, this exercise. So select the rental dates and the return date from the rental table. Select rental date. Where's the rental table? Normally I'm supposed to be able to view it here, but let's see. Select the rental dates and return dates. That's not fair. Supposed to actually see the rental dates here and return dates. Return date. So add an interval of 3 days to the rental date to calculate the expected return date. So rental days plus that should be 3 days plus 3 plus 3 days. That'll be in quotes. 3 days. So if you run the code, oh, why is there a connection? So this is the rental. I was supposed to see this here. Why? Because so this is the rental dates, then the return dates. Select the rental date and return dates. Rental date. Where is the return date? Return date is there. So if I run that again, aha. So if I just expected return date, that's added 3 days to the rental dates. So I'm supposed to select return date, not this is the return date here. It's supposed to be rental date then. So return date. Aha. So that's correct now. So the expected return date is just 3 days. Today is 24, 26. They should return on the 27. We can't see that. Let me switch off my camera real quick. Okay, I'm seeing a comment. Hold on. I'll reply you soon. So 24, 26, and the date to be returned is 27. So that should be correct. So if you're trying to install, why which type of SQL are you trying to install? Hold on, I'm trying to reply to a chat real quick. So the challenge, what's the error you are getting? And did they install it correctly? That is another challenge. So that was correct. So my message didn't drop. Why? Hold up, I'll reply you soon. Hold up, I don't know. I'm trying to reply, but my message is not dropping. I can see your message, Catherine. Just give me a minute. I'll try to reply you. So you can just type yes if you can hear me. So working with Alice. Oh, let's complete this section also. I think that's cool. Working with Alice. I'll just complete this whole chapter today.
Welcome back. Now you will get a bit more advanced as we begin to explore.
Microsoft SQL Server is not free. I said you are installing the free version. So if you install PostgreSQL and MySQL, MySQL Community Server. If you install MySQL Community Server, that is MySQL. Probably you are installing it, you are not installing the wrong correctly. But I'll try to look for a video for you. There should be a YouTube video that you can see. I have SQL Community Server installed in my system right now. Probably the first question I will ask is what's the version of your system? Probably is this your system though. So I'm trying to reply to you. Hold on, please.
Array data types. Welcome back. Now you will get a bit more advanced as we begin to explore array data types. Arrays in PostgreSQL are very similar to arrays in most programming languages. You can create multi-dimensional arrays of varying lengths for any native data type in PostgreSQL. Before we get started, we want to quickly touch on some concepts that you'll be using in this lesson. Most data science requires getting data out of a database using statements. But before you are able to extract data, someone needs to create the database, add at least one table with at least one column, and then insert some records. The create table command, as you see in this example, will create an empty table called my first table with the columns first column and second column defined as text and integer data types. The insert statement example here will add one record into my first table with text value as the value for the first column and 12 as the value for the second column. Now that you have learned some basics about the create table command and insert statements, let's see how you can use these skills to create and manipulate array types. To create an array type, you simply need to add square brackets to the end of the data type that you want to make an array. Let's create a simple table with two array columns to illustrate how this is done. This table has an email column, which will be a nested array of text data to store the email type and the address for a given student ID. The test scores column will contain an array of integer values representing the numeric test score. Once the table is created, we can use the insert statement to add a couple of records to the table. Notice how arrays are represented email and comma separated to store the email to illustrate how this gets to the end. You can use these for the second column, first table, with text value as the value for the first column and 12 as the value for the second column.
Values, text value, text data type. Then Catherine, you shouldn't have problem installing it. The system is a 64-bit operating system. But I'm pretty sure my SQL, that is the community server, will work fine. Probably you're not installing it correctly. Installing the if you're trying to install MySQL, it's kind of tricky. There's a command you have to follow. You go to the MySQL website. Probably you're not installing it correctly, but hold on, please. Just give me like a few minutes. I'll see how we can troubleshoot it. Maybe you have to contact me or just drop a video. I'll drop a link to a video that I'll help you to install it.
As the value for the second column. Now that you have learned some basics about the create table command and insert statements, let's see how you can use these skills to create and manipulate array types. To create an array type, you simply need to add square brackets to the end of the data type that you want to make an array. Let's create a simple table with 2 array columns to illustrate how this is done. This table has an email column, which will be a nested array of text data to store the email
Test data to store the email.
type and the address for a
This address, there's no address here. It says test code. Did you include a column called address here now?
given student ID. The test scores column will contain an array of integer values representing the numeric test score. Once the table is created, we can notice how arrays are represented in the sequence.
This is student ID. The email is work, comma, work order one datacamp.com. Okay, test course. Okay, this an email, another email, order. Let's see.
Equal with curly brackets and single quotations for email. Notice how arrays are represented in the SQL with curly brackets and single quotations for email and comma-separated list of whole numbers for test scores.
Single quotation for emails. Okay. Then comma, bracket here, comma, bracket here, then closing bracket.
Now that we have data in our table, let's see how you access array list of whole equal with curly brackets
1, 2, 3, 4. 1, 2, 3, 4.
and single quotations for email and comma-separated list of whole numbers for test scores. Now that we have data in our table, let's see how you access array data in a select statement. Accessing arrays in PostgreSQL is very similar to accessing arrays in other programming languages. For email, you can get the first element of the first array by using the array notation you see here, with index values of 1. Note
Okay. Hold up. So work at Datacamp. Okay.
that PostgreSQL array indexes start with 1 and not 0. The same notation used to access arrays used in the where clause as a filter. Here we look for records that have work as a value in the first index of the email array. Using standard syntax for non-array columns like where email equals work would actually generate an error. The any function allows you to standard syntax for non-array columns as a value in the first text statement can also be used in the where clause as a filter. Here we look for records that have work as
Can you understand this array data types? My attention has been divided. due to select email one. I need to listen to this again from scratch. So I was hoping I can complete this chapter today. I guess I have to complete it tomorrow then. Mm, so I have to end the live stream right now. I will complete this chapter on Alice on tomorrow's live stream. Waiting for it to load. Come up. My network is not pretty strong. So I'm 40% through the chapter. That's not bad for a start. So I've achieved my daily SP. I think I had a SP of 1K, 37-day pre completed. It took a couple of lessons on data types. We learned about the time data type, arithmetic data types. Not arithmetic, the virtual, string character, and stuff. So that will be the end of today's live stream. Alright, so thanks for staying to the end of the live stream. So if you found value in this video or in the live stream, do give this channel a thumbs up and support the channel by subscribing to the channel so we can reach our goal. So we can get more members to the community of learning tech in Nigeria. So that we have a cool community of tech learners in Nigeria. So let's see if we can build an amazing community of tech learners and enthusiasts. I'll see you on tomorrow's live stream. Don't forget to check out Bengalis BE, which is a freelance client management course by my coach Bengali BE under the YouTube description. Bye for now. Do support and watch the next video on the channel. And I'll see you on the next live stream, which is tomorrow, and probably the next video I'll be dropping. Bye.